In class, you have spent time deriving the law of sines and the law of cosines. These notes are on applying the law of sines and cosines. So in each of these, you're going to be given 3 pieces of information, 2 angles and a side, 2 sides and an angle, and you're going to be asked to find the rest of the angles and sides. So in our first example, we're given angle A, angle B, and side B. That easily follows the pattern of the law of sines. So I'm going to do sine of 35 over A equals sine of 72 over 11. And in order to solve for A, I'd multiply both sides by 11A, etc. So suffice it to say, once I am done that process, I end up with 11 sine 35 all over sine 72. And then I pull out my calculator. Now, a note for the calculator, you're going to really want to double check that your mode, which is this button right here, says that it's in degree. If you have it in radians and you're using degrees, you're not going to get answers that make any sense. So just double check that mode. So now I've got 11 times sine 35 divided by sine 72. And so that gives me an approximate length of 6.63. So now I'm going to do a little sketch of my triangle, because I always find it helpful to have that, which you may have wanted to start with originally. So I have 35 degrees here, 72 degrees here, 11 here, and A is 6.63. And clearly not drawn to scale. Scale is less important at this point, because I really just want to finish getting all the sides and angles. So at this point, I don't have angle C and I don't have side C. However, I can get angle C by remembering that the 3 angles of a triangle add up to be 180. So the measure of angle C plus 35 plus 72 is 180. So the measure of angle C is going to equal 73 degrees. And so now I'm just left with side C. And again, law of sines here works out really nicely. So sine of 72 over 11 is going to equal sine of 73 over C. And so C will be 11 sine 73 over sine 72. So 11 times sine 73 divided by sine 72, which gives me approximately 11.06. And I'm rounding to the nearest cents here. So just to kind of recap, I have angle C is 73 degrees, side A is approximately 6.63, and side C is approximately 11.06. Second example. In our second example, we are given that angle B is 94 degrees, side A is 45, and side C is 55. So unlike the last one, I'm going to do the sketch first. Probably I should have done that on the last one also. That is fine. And again, I'm not drawing these to scale. This is just a sketch to get a sense of reminding myself where all the sides and angles are in relation to each other. So side A is 45 and side C is 55. And so this one is not set up for the law of, well, I guess I could use the law of sines. However, it might be nice in this case, given that I'm given 2 sides and an angle, to use the law of cosines. So I want to know side B. So I have B squared equals A squared plus C squared minus 2 times A times C times cosine of angle B. So I'm going to put this whole long string into my calculator exactly as it is so that I don't lose any sort of significant digits. And then I can square root that, and I get that B is approximately 73.45. So I now have side B, which means now I can go back and use law of sines. Generally speaking, law of sines is less complicated, less work than law of cosines. So that's the one I tend to gravitate towards. So I have sine 94 over 73.45 equals sine of angle A over, angle A over 45. And so sine of A is going to be 45 times sine of 94 over 73.45. So I have 45 sine 94 divided by second answer. Since I already have that answer in my calculator, I can actually keep my answers even more precise by using what the calculator has stored that number to be. And now, of course, in order to solve for A, I need to do sine inverse of that. So sine inverse of that answer gets me A approximately 37.7 degrees. So I now have side B, 73.45. And I have angle A, 37.7 degrees. And then, of course, to find angle C is going to be 180 minus 37.7 minus 94. And again, because I haven't changed anything on my calculator, I actually can use that second answer button and minus 94. So that angle C is approximately 48.33. Okay, and my last example. Is when A is 64 degrees, B is 4.7, and C is 8.1. I draw a little sketch here. A is 64, B, side C. Okay, so I can start by using law of sines here. No, wait, sorry, I can't use law of sines. I misspoke for number 2 also. Can't use law of sines. I actually have to use law of cosines. So I'm going to set up law of cosines here. So I have A squared equals B squared plus C squared minus 2BC times cosine of A. And I'm going to solve this, again, put this into my calculator exactly as it's seen here. So 4.7 squared plus 8.1 squared minus 2 times 4.7 times 8.1 times cosine of 64. And take the square root of that. And so I get that A is approximately 7.37. However, I'm looking at this and I'm remembering something really important from class. And I'm remembering that whenever the angle I'm given, when I'm only given one angle, is acute, I actually have 2 cases to worry about. There's actually 2 options for my angles and such. And so I need to be aware of that this is actually the ambiguous case. So we'll finish solving this and we can say for one case, I have A is approximately 7.37, and I can use the same process I used before. So I would then say that sine of 64 over 7.37 is going to equal sine of angle B over 4.7. So sine of B is going to equal 4.7 times sine of 64 all over 7.37. Again, 4.7 times sine of 64 divided by, and again, I have the answer stored there, so I'm just going to use it. And then sine inverse. So B is approximately 34.97. So then C is going to be approximately 180 minus 34.97 minus 64. So 180 minus, again, that answer, minus 64. And so C is approximately 81.03 degrees. So B is approximately 34.97 degrees, and C is approximately 81.03 degrees. Okay, so a second after turning off the recorder, I realized exactly what my mistake was. And that mistake is that it's not about the acute or the obtuse angle that I'm given. It's actually about the fact that here I'm given a side angle side, which we know from our triangle congruent shortcuts is a triangle congruent shortcut. And that's the same thing I'm given in number 2, side angle side. And so it actually turns out that there is only one answer for both of these cases. The ambiguous case is when I'm given a different set of information. It is when instead I am not given information that corresponds to one of the triangle congruent shortcuts. It instead is when I am given information that we couldn't use for a triangle congruent shortcut. So it would be given if I were given an angle and a side and a side. And you'll remember back from Math 1 and Math 2 that spells a bad word, not a triangle congruent shortcut. So let's look at that. Let's say I have angle B is 37 degrees. And side B is 10 and side A is 4. So we'll draw our picture, and we have A, B, C. So I have 37, I have B, and I have A. And so you saw when you were doing this in class that using the law of signs, well, more straightforward and fast, because this is the ambiguous case, won't give me the two answers. And so what I'm actually going to do is I'm going to use the law of cosines. And so for the law of cosines, I am going to solve for C. So I have C squared, I am going to solve for side C, which means I'm actually going to use angle B. So I have B squared equals A squared plus C squared minus 2AB times cosine of B. And I misspoke again. It should be 2C. So I'm going to fill in what I know. I have 10 squared equals 4 squared plus C squared minus 2 4C cosine 37. And now I'm going to get everything so that it looks like that nice quadratic. So I have 100 equals 16 plus C squared minus, so now I'm going to do 2 times 4, which is 8, and times cosine of 37. And so getting an approximate here, it's going to be approximately 6.39, so 6.39C. And then I get the equation equal to 0. So I have C squared minus 6.39C. 16 minus 100 is negative 84. And I then have, I can use quadratic formula. So C equals 6.37 plus or minus the square root of negative 6.37 squared minus 4AC all over 2A. And I put that into my calculator. I'm going to put the positive one in first. So 6.37 plus the square root of 6.37 squared. Obviously, squaring a negative makes it positive. Plus 4 times 84, because the negative and the negative make it positive. And then divided by 2. And so one answer is 12 is approximately, and this should say approximately also, 12.89. And then my second answer, 6.37 minus the square root of 6.37 squared plus 4 times 84 divided by 2. Negative 6.52. And in this case, it turns out that while I have two answers, and it's the ambiguous case, the second answer doesn't actually make any sense, the negative 6.52. So while this case was ambiguous initially, we now cannot come up with just one answer. So we would have side C is approximately 12.89. And then we would use law of sines to find angle C. So sine of C is going to equal 12.89 sine 37 over 10. 12.89 times sine of 37 divided by 10. And then sine inverse of that gives me C is approximately 50.87. And then to find angle A is going to equal 180 minus 50.87 minus 37, which gives me approximately 92.13 degrees. So again, whenever I have the given information is not a triangle congruent shortcut, it's the ambiguous case, and I need to figure out which of where I'm at. And so I have to do it using a different method, using law of cosines to find a side. And then from there, I will get two answers for my side length. And either both work, in which case I have two sets of answers I have to figure out, or only one works, and I am left still with just one answer.